Let's find both the velocity and the average velocity from a quadratic graph. So it doesn't matter, for this today, it doesn't matter the shape of the graph. For any curve that's not a line, how would you do it? Let's start with the average velocity because that's actually the easiest. So you might remember that the formula for the average velocity is that it is the displacement, which is the delta x, the change in time, sorry, the change in position over the change in time. So average velocity is displacement over time interval. And so now I do need to know, it matters very much on this graph, what the time interval is. So let's do it from t equals 5 to t equals 0. So let's go from the origin and then to t equals 5. So I have that graph for you. It's really hard for me to, it's really hard for me. I don't want to be careful with the glass. So I drew that for you ahead of time with the computer. Basically what you do is you just draw the line from exactly t equals 5 to t equals 0. I think that's called a chord when it intersects the line, when it hits the line like that, or the curve like that. So the delta x is there. That's represented the delta x on the graph. And then, of course, the delta t is down there. So the delta x, you can see, is the full width of this, where the chord intersects with the curve, which happens at 25. And it's minus 0 because we're going all the way down to the bottom. So it's just your 25. And then your delta t is the 5 seconds. So I can plug that in. The average equals 25 meters over 5 seconds is 5 meters per second. So that's the average velocity from 0 to 5 seconds.